All right, everyone. Welcome to the final. Forget to hide your badge in your pocket. MySec for December. Exciting stuff. One quick question for everybody, though. What's a dinosaur's least favorite reindeer? Comment. That's all we got. Yeah, trying to keep it real up here. Let's see. B-Sides was a blast. I want to thank everybody that came out and helped support that. That really helped that event out. That was probably the largest turnout we had in 3 years. So that basically saved the conference. So we'll be definitely doing it again next year. So look out for that. Converge tickets are open for sale right now. I think they're on early bird, so they're $100 instead of $150. If you're a student, let us know and we can get you like a ticket for like 75 or 50, I can't remember. But let us know. And also we're looking for speakers, so if you've got a topic you want to talk about, submit it to Converge or workshop. We have anywhere from 2 to 4 hour workshops in the morning, both days, the conference. We'll have Matt Graber and Roberto Cyber War Dog, which I can't remember his last name right now. That's bad. Will be our keynotes as well. So, yeah. With that, I'll turn it over to our first speaker.
Okay.
You excited?
Sure. I'm woefully unprepared as it's finals week, and I threw this together in the last couple of days, but
Perfect.
I vaguely know what I'm talking about with it because I did it. So RuCTFE was 3 weeks ago now, I believe, maybe only 2, and there was only one service were we able to find a vulnerability in, or at least exploit.
I'm breaking you.
All good. So that service was Patrol. So if you don't know about RuCTFE, they distribute some images. You just pop open some VMs, and that's your playground. There's a router image and a vulnerable image, and they run a scoreboard service. It pulls a bunch of, in this case, it was web apps running in Docker containers, and it sends flags to everyone's server every minute. The flags are active for 15 minutes, and you just need to get as many flags from other people's services as you can.
Just ignore that.
So my slides aren't loading here either. So we were digging into a bunch of the source code from our VM, and Sam Shrum found that one of the services looked like it wasn't doing all the checks that it might have appeared like it should be doing. The service was called Patrol, and it was supposed to be like the navigation system for a submarine that was run by these web apps. There was one managing users, one managing engine, and this one Patrol, which you could query and get graphs, and then it would ask you to solve those graphs either with a vertex cover or a permutation. But looking in the source, just looking through everything, you had all these things. You can request a graph, you can send it that graph to tell it, hey, this is the one I want to solve. And we dug in and send a permutation, because that's the one I decided to dig into, because I don't know what vertex cover solutions are. I don't know how to even approach solving them. Whereas a permutation graph, I know a little bit about, so I figured I'd dig into their 50-50 chance of it being the vulnerable part if there's only one vulnerability. Would be nice if it would load slides. Can't edit offline. So I dug in anyway, and it was actually just checking that the solution you submitted was a subset of the edges of the existing graph. I dug a little further. It turned out it was checking that both were actually just equal sets deeper in. So you could just submit the same graph back. And that was your permutation solution, but you had to dig a bit deeper to get a flag out of it. It would, when you sent it your edges, your solution for the navigation, it would just return continue in all caps. So why not try it again and again? Turns out if you dug into the source code, you'd see that you had to do it 7 times and you got a flag back. Hooray! But possibly. I can't download the slides because I'm offline.
Oh no.
But so we looked into the source, we found some of that, and we decided to sort of manually check that this worked. We went through the list of steps that we would have to go through to get a flag. List returns all the graph IDs. Get graph returns just a massive graph. It was 1,200 vertices, as many edges as you can make between those, and weights for all those vertices. I was horrified by this when I saw a massive return just scroll through the terminal. I'm like, I don't want to dig further into this. So I actually proposed that instead of trying to solve a permutation, instead of trying to even send it back the original graph, because that would take storing the graph and actually dealing with it, I just said, let's just send it back a list from 1 to 1,200. That's the number of vertices we have. We should get an error back from it, from this. We know what we're doing is correct. We know we have IPs that work. We know we're getting graph IDs. We know our request ID is valid. But when we send it that garbage, the 1 through 1,200, we get continue. So we sent it 6 more times, and it just gave us a flag. That flag was not a valid flag. It had expired at that point, and we weren't going to go and check like when a new graph ID appeared. So we automated everything, and we began scanning every IP for the port that this service ran on. And then any IP that the service ran on, we created a new job. We parallelized it as best we could in the world's shittiest Python and Bash exploit that's ever been written. And for each of those, we would then grab all of the graph IDs and spawn a new job for each one of them. Each graph ID would send a request. And if we got continue, so if the person had not patched this service, we would get continue from this just garbage being spewed at the system. And if we got continue once, we sent it 6 more times, got our flags, submitted the flags, and in our first run through all the IPs, we went, from getting the first flag, we went from about middle of the scoreboard, because we had services up, but no flags. That got us to about the middle of the scoreboard. Just running it once got us in the top, just getting 1 flag got us in the top 3rd when we ran that. And running through all of the IPs got us up to, I think, a peak of 82nd on the scoreboard out of over 360 teams. So this service, apparently not a huge amount of people found vulnerabilities in, oddly. It wasn't the most exploited service. Somewhere. Yeah. So we got this when we submitted the first thing. That rec ID, it turns out, could just be anything. You could put anything in there. When you requested a list of graphs, it gave you all of the graphs and a big list of rec IDs, which were all unique and all had not been used, all were valid. And the moment you used the rec ID, it became invalid once you got a flag or a failed flag. But you could just change characters in it, and that's how we did it. For each new job, we just incremented it by 1. And those were all valid. We found 1 team had patched it. Only 1 of the teams we hit did we fail because we submitted a wrong permutation. And I did not get around to checking actually, I can't check the IPs because they anonymized it. I was going to say it was probably one of the leading teams, because it seems that with how the scoring system in RuCTFE works, it does quite heavily prioritize blue team. When you lose a flag, you lose points and your multiplier seems to go down, or you just lose what flags you have gained. So if you get 300 flags like we did from our first run of patrol, if you then don't run it again and don't get new flags, and people get flags from your service running that, your flag points go down. They don't just decay, but it's for every flag grabbed from you, you lose a flag. we eventually started running this exploit over and over and over again, just saturating our network connection with these requests, and our flag points were staying about the same because people were grabbing flags from us as quick as we were grabbing from them. I already talked about the automation. Oh yeah, the permutation part. The reason I did not want to, it's not going to load. The reason I did not want to actually solve this is that both permutation and vertex cover are MP hard. They're both really computationally expensive and on graphs of 1200 points. So a permutation graph is such that if you do your, I don't know what the graph on the bottom is actually called, where they cross are where you get edges on your graph at the top, or if you write it out as permutations, if you have them in order, it tells you nothing. Whereas at the bottom, if you look for any numbers that do not appear in order, I don't know the best way to explain that, but say 3 and 1, 3's appearing before 1, so that's out of order. The location of 3 is lower than the location of 1, and 1 is lower than 3. If those two things are true, then you get an edge. So in this case, there is an edge between 1 and 3. Whereas 4 and 5, the location of 4 is lower than the location of 5. 4 is less than 5. You have an edge between, you do not have an edge between 4 and 5. This gets really hard to compute when you're talking 1200 vertices and however many edges can exist between those. It's the scoreboard server, however, because it was generating those graphs for you, it already knows that. It's probably computed it from an existing permutation. So it was querying our service with correct permutations. That's how you would, we didn't have time to get around to this, but that's how you would approach the blue team side of this. You'd patch it with actually verifying that the solution is valid. You'd dig into, these aren't going to load, but in here, not in that one, in the check perm, which I don't have a screenshot of, you would implement it, recompose your Docker container, and have that up. And then the scoreboard can still submit, but people trying to throw this garbage cannot. And then you could do the same thing for vertex cover. And while doing this, our blue team side discovered that people could just send 1201 vertices at it, and it would take down the service for about a minute. And the RuCTFE scoring is based on your uptime as well. You have a multiplier from your uptime. So if you can take down someone's service, not only are you denying other people flags, but you're decreasing the multiplier on their score at the end. So once you've grabbed all the possible graph IDs from a system, you can then just send it 1201 vertices in a check perm. You crash their service, they're going down in uptime, and everyone wins. We didn't get around to implementing that in our script, but after running it each time, we would send a request to all of the existing IPs and take them all down for a little bit. Patrol seemed to be the only service with a really easy denial of service bug, because no team other than the teams I believe who patched the permutation solution were able to keep Patrol running for more than about 60% of the time. Over 8 hours, they only had 60% uptime on the Patrol service. The Python script, I think I actually have open. Yeah. So our exploit ended up looking like complete garbage. Don't know how readable it is, but me and Violet worked on this. I don't know if any of you will have met her, but we were working on this, and we're both most comfortable in Bash and Python, but we aren't comfortable enough in Python to do proper web requests with it, so we were doing those in Bash from system calls in Python. Not the best idea. Got it done. Apart from our file in out, because you can't take the Python console out and like pipe it to Bash or Bash standard out and just pipe it back into the Python, not sensibly that we found at least. So we had all of these files. This is the failed request. We had 2 of these files for each IP, which is where it gets really broken. This is the failed request. This was a successful request. And this is what it would look like when you got the graph list. Every single one of these is a graph with 1,200 vertices. Again, why we did not want to do an actual solution. And each time you would get a graph that looked like this. Bunch of edges, list of vertices, and somewhere way down at the bottom, all of your weights for presumably one per vertex. Not entirely sure. Each of these you'd have to solve. We did not want to do that at all. I'm glad our script worked. I don't know why it worked, and once it was running, we started looking at the other services. We were close to finding a vulnerability in one of them, and sadly, a big group of us were dedicating our time to a service called Engine, which when RuCTFE shut down the servers and released their GitHub data section on exploits, which had what they'd intended as the exploits, which this was not the intended exploit for Patrol. Instead, they were expecting you to solve it, but it didn't care about the weights. It didn't just not care about the weights, it didn't care about anything. You could throw it 1 through 1,200 and it worked. Engine had no exploits. The author of it had stayed up for the 3 days prior trying to get the exploit working in the service, but couldn't. And they left the service in the image, just kind of as a red herring, that if you spent time on it trying to develop an exploit for it, either you'd find something that they'd not intended, or you'd just be wasting your time. And we ended up in that second group spending loads of our time trying to exploit what seemed to be a secure service. So I think that's all I have to say about the time at RuCTFE. It was great. It was my first CTF, and I was able to grab flags, so I'm pretty proud of that. So, yeah.
Overall, how would you generally describe the whole event? Like the
It was
layout,
really
setup,
good. It was a bit chaotic at first. We had some networking issues. There was supposed to be a safe Wi-Fi and it wasn't working properly. The web app firewall wasn't working quite as intended. It was working with the test image, but the moment the actual game went live, the scoreboard server wasn't able to see any of our stuff, even though it was able to see the fake services in the test image. Who knows, we took that down, so we had no WAF. There were a few other odd networking things right at the start, 2 bad cables, a bad port on one of the switches. We were seeing like 1 meg to the outside world when it should have been gigabit all the way. Stuff like that was a bit chaotic at the start, and then there was no real leadership to it, so you kind of had to find what you were doing yourself, which I think is what led to us not getting anything. We found a number of ways to patch vulnerabilities, but I think we only got one of those patched before the end, because we had no one spending their time doing blue team stuff beyond monitoring our flags being stolen, which at that point it's too late. So other than those 2 things, it was really good. Thank you.
Okay, is it good? Okay. Okay, so my presentation is on on security problems with PHP. I had a database class that I took this semester, and our semi-final project was to investigate certain topics within database, and within the class, PHP was one of those topics. It started off as introductions to PHP, but I've modified it to be security problems with PHP because it's the world of cybersecurity. So what is PHP? So it allows pages to be dynamic. Similar to JavaScript, it allows your pages to have functionality, similar to having, if you're logging into your credit union or filling out forms or completing requests, there's action happening in the background that allows your website to have more functionality beyond just a static page. So redirecting the forms, handling database content, and securing logins and permissions. And it's embedded, it's an HTML embedded language. So when you're programming with PHP, you'll oftentimes embed your PHP scripts in your code for your website. So you'll have single HTML file, and you have your PHP scripts most likely inside of that. And PHP is one of the most popular languages for dynamic websites. Currently 52 million websites are using PHP. And it's more popular than JavaScript due to it's more applicable to legacy applications, and a lot of current applications have reliance on it because of that. So kind of the history of PHP, more of an introduction for it. So it started off as a home project, similar to a lot of like open source projects, like Unix, and like Linux and stuff. So these two people rewrote PHP from the ground up. So there's the original creator, started off as a home project, and then two other people rewrote it and released PHP 3 in 1998. And then this is where the project kind of took off. This is around the time of Netscape, and yeah, yeah. And before that time, there was the original developer on the project. And then in the year 2000, PHP 4 was released, and the Zen Engine was developed. It was written in C. Engines these days can be written in multiple languages, like in Python or really anything. And then in 2004, PHP 5 was released, and then they rewrote the engine for PHP 5. So the first engine wasn't doing it how they wanted it to be. So they rewrote it, and it allowed for more object-oriented programming. PHP is very Pythonic, so you'll see a lot of variables, and a lot of your actions in PHP will be very similar to Python. So if you can program in Python, most likely you can program in PHP. So object-oriented, you could access databases, and performance increased. This is also around the time that they introduced support for 64-bit. So the performance increased around that time for the engine. So the development of PHP 4.49, so the security updates stopped for that in 2008, and PHP 5.0 is the version that you would most likely have. And there wasn't any Unicode support at the time. So that was a big problem with the development of PHP, is there was no Unicode support, and they were actively looking for developers to add this to this application. Between 2009 and 2014, still didn't have Unicode support. That was one of the main gripes about PHP. And that kind of left PHP 6.0 unfinished. And then PHP 7 released in around 2014, and then they rewrote the engine again for PHP 7. So it's gone through a lot of recreations, trying to add different features to it and increase the security, and allow easier use of this programming language since it was developed in the early 2000s. They're trying to keep it up to date. So the Zen Engine is very interesting because it has a compiler and a runtime engine. So it's written in C, but it can compile certain parts of code, but also similar to Python, you can run portions as well. So yeah, let's face. So the security issues with PHP. So one of the main security issues that you most likely have heard about is SQL injections. So SQL injections is where you would put a piece of SQL command like x equals x or something along those lines that is out of the bounds of your input. And what will happen is it'll read that as a SQL command, and most likely, if you don't have the proper precautions in place, you'll actually get feedback that you're not supposed to have. So people can drop entire data sets or databases if you don't have the proper precautions in place. And then cross-site scripting is an injection of code into the PHP output on a site. I believe this is similar to Burp Suite. I could be wrong though, like modifying requests and PHP requests. And then source code revelation is in the case where you're able to break up Apache or the web server in a way that it responds and shows you what the source code for your PHP is. So once they know your source code, they can most likely reverse engineer and find an exploit for it. Second part of security issues is when an attacker does gain access, they can include a remote file that gets executed, and when that gets executed, that will affect the host that is serving this website, this PHP website. This can be bad for your databases. This can be bad for the system in general. Session hijacking. This one's actually very interesting because every time you submit a form or you're logging into a website with PHP, you have your own unique session ID. That session ID can actually be stolen and reused. And once you reuse that session ID, it's almost as if you're the user originally authenticating. So that can be bad in situations. Online banking, you steal somebody's session ID, you take it, you put it as your input, and you're automatically that person logging into banking credentials. So that's one of the worst things that could happen to you if you were caught in a situation where somebody's hosting a vulnerable PHP backend, and you somehow get your session hijacked. Cross-site request forgery. So it's somebody retrieving your PHP request. So you send a PHP request, they retrieve that request and send it as if they were you. So very similar to a man-in-the-middle attack, except for it's in the world of PHP, essentially. And then directory traversal. So if you're doing CTFs, like directory buster or something along the lines where you can view the directory of where you are on that web server. So if you're accessing a website that's using PHP, you can send remote code to it and get access to all the files in the directory, and that's not a good thing. So functions in PHP are not case sensitive, so you can put anything in there. As long as it's a valid command, it doesn't matter. They all do the same thing. And then comments, if you've seen comments before like this is like Java comments, I believe. It's other languages as well that use this. Very common. And you can do mathematical operations. It's very similar to Python. So here's the syntax. So you have the declaration that it's HTML5, and then you have a normal HTML body header kind of format. And that's echoing hello world. That's what PHP is doing. And it echoes hello world. And if you're trying to gather information from the host, if you ever set up a LAMP stack, this is one of the common commands you would do to access information of the box. You do PHP Info, and that would call back to the box that's hosting and pull up information about the box. I run this in WSL, so it's Linux on Microsoft. It has its own number, and I'm running Apache, different information. But say, for example, somebody was able to inject PHP Info into their request, and they were able to retrieve information about your version of Apache, your PHP version. I'm running 7.2. They could use that on SearchPloy and look up what version you're running and see if there's any exploits available or similar processes. So these are like the variable declarations. So if you want to declare hello world as text, it doesn't matter. You don't have to tell it to say it's a string. You don't have to say it's a float. It automatically knows that you're talking about a number, you're talking about a double or something along that line. So showing how it's very similar to Python, you have your two variables, so opinions is the worst language. And then you have your two variables for numbers. And you're just printing output. So if you can see the header for this is just PHP, and inside of this you're doing mathematical operations. So you're printing the output of X and Y, and then you're also printing the two headers as well. And then you're assigning those headers to types of an H2 in HTML will be a certain category of how large the text is supposed to be on the website. So you can assign those things to it. And then that's what it'll print. Java is the worst language. And then it'll add your numbers together. Okay, so here's where like more of the statistical data comes from. So for May of 2019, on the right, this is a pie chart showing this what version of PHP people are currently using. So as you can see, people are using, about 40% of people are using PHP 7.2, which is most up-to-date PHP version. There might be PHP 7.3, I'm not sure though. Yeah, so the three most up-to-date PHP versions. But if you look down here, support for 7.0 actually stopped December 3rd. So everybody over here is extremely vulnerable, and I guarantee if you look up anything on SearchPloy, you can probably find a remote code execution or something along the lines of executing a process against a PHP server. There's exploits for PHP, and they've rewrote the engine multiple times to try to fix that. And then the vulnerabilities by type. So cross-site scripting is the most common, SQL injection, and then file upload. And the reason some people don't update their PHP versions is because they have legacy applications that are using modules that maybe are out of date but are not compatible, or flags that are depreciated that they're still using, they just haven't updated. But generally, you want to keep your PHP up to date. It's bad if you don't. So what to take away from this? So server-side applications such as Node.js are new, and they do almost the exact same thing as PHP, arguably better. So switching to those kind of applications, although not ideal, would help prevent a lot of these issues. Make sure like any content that is input, like any input for a form is pre-prepared. So you know what content you want to be allowed and what content you don't. And then keeping your instances up to date. So you don't want to be using old statements. And then also a shout out to colleague, co-student, I don't know, a student a student in my classes that helped me with this. We had took the class together, and this was our presentation. So.
Hi, everybody. I'm Kyle. And I'm a failure. So, an IT update went off and actually broke a majority of. You guys anybody here use Snagit?
Why does it say PowerShell version 1.0?
So, if anybody uses Snagit, you'll know that when you take your captures, it actually keeps an archive of everything you've taken a picture of. I foolishly have been using that as a backup for all of my fun pictures for like different incidents I've gone over, things like that. I should check them there. 1 second. I gotta click things. Whoop. Hey, okay, yeah. So basically, a lot of fun examples that I want to put together don't exist anymore, so I'm super sad. However, the point of my talk, for the love of EDR, is from here on out, every time I come across something kind of unique and interesting that happens or we see in our environment, I'm going to bring these up. But I'm also going to pair them with regular IT functions. And so the question for you guys is going to be, which one's IT and which one's an attack? So here's this first one we're looking at right now. And what would you guys think about this one so far? Would you say this is potentially more malware looking, or would you say this is normal business? Dun, 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 dun.
Or just open answer?
Yeah, just open answer.
I would say it's not business.
No? No? Huh? All right. What vendor in their right mind would PowerShell encode something? It's good. This is legitimate. I forgot the actual software name, but what this command up here is doing is it's setting an environmental variable to set its PowerShell execution to execute anything, right? So depending on the environment and with PowerShell, it'll start off as like signed only, depending on who you are, and you can change that pretty easily if you're an admin. That's all that thing is doing. So it's an encoded, hey, check to see what the current execution policy for PowerShell is. If it's not this, set it to this. And this vendor is just like, we're going to be cool. We're going to encode that. Yeah. And it's, again, MSI.exe. It is an installer for software. However, it's just as easy that someone could name their malware that. In fact, some people do.
Is this actually legitimate?
This is legitimate software, yes. It's installing. Yes, it's installing like a crazy man. Oh, yeah. Right? Isn't this fun? Okay. Next. So you've got Explorer. So remember, Explorer is going to be what you log into. It's your GUI environment. So anything that you open and double click on, Office, Excel, blah, 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 you're going to see that spawn a child process in Windows, and you're going to have those applications running. So this person has Explorer. I cut off the E, my bad. And we see WScript executing. Going a bit crazy. So what do you think? Evil? Welcome to my life. Now, just, also, like when you're looking at stuff like this in EDR, how many people are familiar with EDR, by the way? I forgot about that. So in EDR, you're essentially gathering every single process execution. You're grabbing the metadata. You're able to do this by either having your own kernel driver that taps into the Windows kernel, or you can tap into some of the functionality that Windows provides for security events. So you can get basic stuff like, hey, process creation, process termination. You can get files created, files deleted, registry edited, deleted, network connections. A big one would also be libraries loaded, right? That could be really useful if you're trying to like write a rule, or you're looking at something like, why would this ever load, I don't know, a driver that's used for making network connections, and this is something that shouldn't make network connections, like, I don't know. Unfortunately, all the examples I just thought of all had legitimate reasons to do it. So I'm like, oh, Notepad. I'm like, actually, Notepad has some. And I'm like, anyway, this one is actually really cheap ransomware. So what happened for this user was, once they logged in, explorer.exe. So you'll notice one thing to think about is wscript.exe. How would you run that as a user? If you open up command to run it, you're going to see Explorer, command, PowerShell. You'd see Explorer, open PowerShell, and then you typed in wscript in your scripts. All right, you see that parent-child relationship. But this is opening up straight from here. So either if you did I can't remember correctly, but if you did like a start run wscript and dropped your whole like line in there, that might work. Or if in this particular malware's case, it's just a run key. So as soon as the user logged in, Explorer is created, it launched as basically a persistent mechanism its malware, which was wscript, which then launches all this crazy madness using, files and things that it needs. The A's is the actual ransomware itself. And it just goes to town. It's going through, it's just rewriting. It was rewriting just like half of the file as to be encrypted, so you couldn't just open it with normal tools. But eventually you could actually reverse that pretty quickly, grab the key because the key was actually in the malware. So you're just like boop, 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 and you're in decrypt and life is good. But yes, that one is actually ransomware. So this one gets a little crazy. So we have PowerShell again, executing wscript, launching a crap ton of cmd.exes. So what are these things doing? And when we look at it, we can see the command line process is showing net show, namespace, show effective, and then it's piping the outputs of those commands to an actual file like dns.exe text, right? Looks like it's kind of capturing stuff. And if we keep scrolling through some of these, we've got more where it's like, okay, net share. So it's getting any network share connections that it has, and it's dumping it again to a config file sharing.txt. It seems almost like some kind of scary reconnaissance going on, wouldn't you think? What? No, you don't know that. I mean, this is just, well, I mean, would you just steal your Windows firewall configs and drop them into a file like that?
This is somebody's way of automating the setup or configurations.
Maybe. So this one is just legitimate activity. There's a script in C, Windows, System32, gather network info.vbs. It is a Windows diagnostic script that runs through and grabs all these all this. Great question. This is the magic of Windows. So you'll see this thing echo off from time to time, and as an incident responder, you're sitting there, and then you see file like creations for like your network communication, dumping registry stuff, all of these text files. You're just like, what is going on? And then you realize that this wscript that it's actually executing, it's a legit Windows file. So that's kind of cool. So if you're an attacker and you want to collect data off the machine, just run that. And it's like, oh, of course. All your EDR, like you're going to see your support people troubleshooting servers, troubleshooting machines. There's functionality where you're going in through the Windows diag, like troubleshoot. It'll run that script. So you'll see this thing spawn, this W script will spawn from different areas. NetSH.exe, which is used for a lot of network stuff, you can actually trigger that script and you'll see a spawn process of W script and then spawn, all this madness. So if you're writing rules in EDR, where you're trying to look for these behavioral patterns of what's going on, instead of just a signature like an MD5 or something like that, you're like, hey, whenever I see a script do something like that, let me know. And so you'd have to write a rule to basically negate this stuff out. But if you're an attacker, you're like, well, now I can just run this, and it's probably going to go by potentially their EDR rules. Wow. Outlook. Word document. W script again. This is just another piece of malware.
Okay.
Yeah.
I was saying this was obviously bad, so is it good?
Excel. PowerShell. So the difference between Word, writing rules like this for Word and Excel in an enterprise, Word you rarely have ever really have this going on. You rarely are ever going to see a child process created off of WinWord for like PowerShell or WScript or any type of thing like that. When that happens, it's a really easy thing to indicate and be like, ho ho. And today, attackers are actually bypassing this altogether. They can bypass a rule where you set up like, hey, anytime that I see a parent process of Outlook opening up WinWord that spawns command or PowerShell or something evil, right? They were able to start bypassing that because in the macro, in the VBS macro code that they actually wrote, they're actually calling WMI, which is a Windows Management Instrument, I think. I don't remember the I. Something like that. The WMI, you can make basically, it's like a service call within Windows. So you will not see a child process created. You'll basically see a thread or a communication to the WMI service, and you'll ask that to spawn PowerShell command and everything else. So then that rule that you may have had for like years, you're like, haha, I'm always catching these guys doing evil stuff, it doesn't work anymore because they bypassed it. And it's always changing like that, so you always got to keep an eye on it. Excel, on the other hand, everybody loves Excel. They love their macros. They do stuff like this all the time. I had like 30,000 or 60,000 hits for like the last 2 weeks on just Excel doing stuff like this in our company. So it's like, it's really hard to write rules on that unless you start getting a lot more data. And what I mean by that is you could start looking at like, hey, parent processes of Excel. Well, when we look at PowerShell, what libraries did it load, right? Did it load PowerShell libraries? Did it load things that are not normal for just a generic PowerShell execution, right? Or did it make network connections? Did it touch certain registry keys that would be kind of sensitive or something like that, right? There's a lot more context and a lot more data that you're going to find in your EDR products that'll be able to help you figure out if this is actually good and bad. But sometimes you won't have anything. You may not have actually anything in just EDR alone that'll help you figure that out, because it may just be a limitation of that tool. Because you can think about it, EDR's entire premise is kind of describing like the information that's most important that you would need to like kind of have visibility in your environment. If you grabbed everything, every single like thread execution, every single like API call that a process makes, it would just destroy your performance. Like you would kill a machine if you were collecting all that data. How many people here are familiar with sysinternals? So sysinternals has a system monitor where you basically turn it on. You can watch every single one of those threads execution and process activities, files, reg, and you can see how fast like that just blows up. And it will just consume a ton of resources if you let it go on. So that's why like you'll always have some type of potential limitation on what you can and can't do with this data and what rules you can make. And at that point, you start getting more creative. So and you take this data and you put it into a larger like data lake with other data. And then you can write join queries and everything else and start combining multiple sources of information. Like, okay, so what if we got all the firewall activity logs and combine that with the endpoint process execution and timestamps going on, right? Or what if we did behavioral analytics across all of that and be like, hey, does this user ever even open PowerShell? And then all of a sudden they're opening PowerShell all the time, or they're doing activities like that, right? More stuff that you could narrow down and basically have your focus and start digging into a machine to figure out if it's actually bad or not. And here's an example of what I was talking about. So again, this person was doing some IT troubleshooting, and they ran a network information, or there's like a trace function. I can't remember which flag it was. And that's what triggered off that entire thing. Again, freaked me out. I was just like, what? Yeah, that's all I got. A little quickie. Any questions on that stuff?
That was fun.
Yeah. It's really fun until...
Internet users, what is CPR, or what is EDR?
For which one? For
For the sake of the internet users, what is EDR?
Oh, endpoint detection and response. Good point. Yeah, that's the other half of EDR. So a lot of the visibility I'm talking about right here is cool. Your next pieces of EDR platforms that are out there, because just like antivirus, right? There's tons of vendors. They all have different pros and cons. The next part is your response, right? Whether your EDR platform allows you to write a rule and see this, cool. Can it stop it? Does it allow you to do that? Does it allow you to isolate that box remotely? Does it allow you to like start running forensics tools on it, pull memory, start dumping like all activity you got off it, right? That's where the other half of like the platform comes into play. Because if you just have like just visibility, it's just like monitoring, right? But it's that detection and response capabilities. Really cool stuff, a lot of fun. My favorite part of my job. So, any other questions? Let's check the internet. Whoop. Nope. Cool. Well, that's all I got. See you guys next year.